Hello dear students, today we will discuss something regarding the shapes of molecules. We discussed regarding the postulates of whisper theory. In today's class, we will understand how we should have to predict the shape of our molecules with the help of whisper theory. Now, let me consider example of beryllium chloride. When you consider beryllium chloride, very first need is we have to remember the atomic number of the elements. It is mandatory that we need to remember the atomic number and their configuration minimum up to 40 elements of the periodic table. Atomic number up to 40 we have to remember. It's very mandatory to learn in organic chemistry of first PUC as well second PUC. So for example, I have beryllium chloride. So in this beryllium chloride, I must have to consider atomic number of beryllium. Hydrogen, helium, lithium, beryllium. With atomic number 4, the configuration would become 1s2, 2s2. Right? 1s2, 2s2. Beryllium is the S block element. Now let us consider chlorine. Chlorine with the atomic number 17 comes under the P block element. Let us write the configuration. So it is 1s2, 2s2, 2p6, 3s2, 3p5. Right? And these are said to be valence electrons. 6 plus 4, 10, 15, 17. Now we are supposed to predict the shape of this molecule. Let me consider first a valence electrons. Okay. Valence electrons if you consider for beryllium. Right. So it has 1s2. Don't bother, this is 1s2 electrons because they are closely associated to the nucleus. We cannot take those electrons away from the nucleus because they are strongly attracted towards the nucleus. It is only 2s2 electrons we can take for the bond participation. Fine. Now, so these are said to be 2s electrons. Let us write the outer shell electron for chlorine. So for chlorine, these are said to be inner shell. Leave them. These are said to be outer shell electrons. Okay. So now you can see here there are 5 electrons are present in the p orbital. Let us consider first 3p5. So 3p5, how you are going to represent in the block? So 3p electrons, 1, 2, 3. How many are there? There are 5 are there. 5 electrons are there. Fine. So these two are said to be ground state electronic configuration for beryllium and chlorine. Ground state electronic configuration for beryllium and chlorine. Now, if you want to do hybridization here, there is one p vacant orbital is there. Don't worry about the hybridization term what I pronounced now. You just need to remember the shape of a molecule according to this configuration given and according to the number of electrons they can accommodate. We are going to learn in detail regarding hybridization part in the same chapter very soon after this one. So don't worry about that one. I will give you very nice explanation for the hybridization soon after the completion of this one. You don't worry about that one. Okay. Now, so just you remember these s orbitals of beryllium, they will undergo hybridization because I have 2 of such p orbitals. Yak ಹೇಳ್ರಿ ಎಷ್ಟು ಅದಾವು Cl ಇಲ್ಲಿ 2 Cl are there. So let me consider the other Cl also. I will write each and every point for this example. For the next examples we go for the shortcut. So this is said to be again 3 orbital of other chlorine atom with a 5 electrons. This is also P. See, there are 2 electrons are present here which are considered to be valence electrons which can be given to one chlorine as well as to the another. Okay. Once these 3 orbitals, that is s orbital of beryllium, p orbital of chlorine undergo hybridization and they will arrange. So let me write 2 p orbitals of chlorine. This is first one. The same I would be writing like this. This is second orbital. Imagine it is the orbital for beryllium. Same orbitals will be present for chlorine also. P orbitals we will be considering. After hybridization, they will be becoming like this. And I will give you clear explanation regarding the hybridization. You don't worry about that one. Fine. So this is beryllium. At the center, we have minimum electron cloud. Now, I have p orbital of chlorine also. See how they looks like? They will be like this with 1 electron each. This is 3p orbital of one chlorine. This is 3p orbital of another chlorine. Now see here. I will mention those two electrons of beryllium. Beryllium electrons are 2. Now, how does bonding takes place? The one electron which is considered to be valence electron of P will get combined with this one. It will get combined with this and there will be a bond formation takes place. Similarly, the other p orbital will get combined here and again bond formation is going to takes place. Now, this darker place indicates it is the bond. So it is said to be at the center we have Be and at the opposite side we have ClCl. Exactly it is showing us a linear geometry. Means at the horizontal there is a head-on overlapping of orbitals of beryllium and chlorine is taking place. Now this geometry indicates that it is linear in shape. Linear in shape. And bond angle turns to be around 180 degree. It is 180 degree. Can you see here? This is only s orbital of beryllium and only p orbital of chlorine are involving in bonding. These are only the orbitals are involving in bonding. So can we call it as sp hybridized? I will explain these things in detail, don't worry. But remember, this is said to be sp hybridized. Sp hybridization we can call. So this is all about the prediction of shape and geometry of beryllium chloride molecule. Similarly, we need to understand the shape and geometry for BF3 molecule, methane, ammonia as well as water molecule. These seems to be very simple, but I suggest there is a requirement of minimum one time practice. If you practice this just by one time, definitely you are going to remember the things very easily. And such questions can be asked for 2 to 3 marks in your board examination. These seems to be most important. Do remember, they are very easy also. Just by practicing one time, you will memorize them in a clear manner. Do copy this. We'll move to next molecule.